why data analytics matters in retail. In today's digital business generate massive amount of data daily, but raw data alone isn't helpful. We need to turn it into actionable insights. This project uses the global superstore dataset from Cargo to uncover trends in sales, profit, shipping, and customer behavior. The primary objective of this project is to leverage data exploration and visualizations technique with tools such as Power BI to detect trends, patterns, and potential business insight from the data. This project aims to uncover trend and pattern in global retail data to support strategy business decisions. We walk through the full data analytic process from data cleaning and transformation in Python to visualizations in Power BI. The goal is to generate insight on sales, profit, customer behavior, and shipping performance using descriptive analysis. The dataset used for this project is Global Superstore Tool, which contains historical retail transactions records from various regions around the world. Each row in the dataset represents a single order, and the dataset includes a wide range of information as shown in this table. So, the data span across the region and include details like customer names, product category sales, discount, profit margin, order dates, shipping mode, and more. This wide range of data makes it perfect for exploring various business angles such as sales trend, customer behavior, and logistic performance. To be able to conduct meaningful data analysis and build interactive dashboards, we have chosen a set of important variables in the dataset that serve as the foundation of most of our visualization in the Power BI. For example, sales, which is the total revenue generated for each item source, which is our primary financial indicator. Profit, the net gain after subtracting the cost used to identify which product or region are most profitable. Quantity, the number of units ordered for each product, which is helpful to analyze the demand and trend. And next is discount, the percentage reductions applied to sales. We use this to study how it impacts the profits. And category, the top level classifications of the products, such as the furniture, technology, or office supply. And the subcategory, which is the more specific breakdown under each category. And the region, which is the geographic region where the sales around used to compare sales across different markets. And segments, the type of customer, either the consumer, corporate, or home office, which help us to segment our customer behavior. And last but not least, the order date and the ship date, which is the date for the order was placed and the date of the item was shipped. We can analyze the delivery timeline.
Moving on to the next crucial step, which is data pre-processing. In this section, we identify data structure, went through data cleaning, data transformation, and data manipulation, all by using Python scripts. Data structure is identified because it helps us understand the type of variable we are working with. This allows us to apply the right pre-processing techniques to each data type effectively. In short, we have identified four types of data, namely categorical, string or text, numerical, and date. Moving on, we start the data cleaning process. As you can see, the postal code column contains a lot of missing values. By inspection, more than 15% of the data in this column was missing. So we decided to drop it entirely to avoid bias and maintain the quality of our analysis. To detect missing values, we use these Python scripts. It checks each column and records how many values are missing. If no missing values are found, it simply reports that the dataset is complete. Then, based on the results, we apply a rule to draw any column with more than 50% missing values like the postal code column shown earlier. This helps avoid bias and ensures our analysis is built on reliable data. Next part of data cleaning is to identify duplicates. Although no duplicates were found in our dataset, we still included a script to detect and remove them as precaution. This step ensures the integrity of our data, especially in case new records are added later on. To avoid issues with inconsistent date formats like 18 January 2023 or 18/1/2023, we standardize both the order date and ship date columns in the last format shown in year-month-date. We also removed rows with invalid or missing dates to ensure smooth timeline-based analysis. Next, raw dataset often contains imperfections such as leading or trailing space in text columns, which can interfere with grouping, filtering, and matching operations. Therefore, text columns were cleaned by trimming unnecessary space at the beginning or end. This avoids errors during filtering or grouping like treating New York and New York space as different values. Moving on to the next section of data pre-processing, data transformation and manipulation was done. To enable time series analysis, we extract the order year and month from the order date column. Then, we calculate delivery duration by subtracting order date from ship date, which help us measure shipping efficiency. We also added a new column to calculate the profit margin for each transaction, showing how effectively revenue is turned into profit. A binary flag named is profitable was also created to quickly identify whether a sale made profit. Lastly, we categorize each transaction into revenue groups ranging from low to extreme based on sales amount. This helps simplify the comparison between small and large orders across different visualizations. This is our final dataset after data pre-processing. We successfully added new columns during data transformation. All changes were stored separately from the raw data, clean data, along with a generated report for review. This is the report that shows a summary of our cleaning process in the Excel file. We removed the postal code column due to over 50% missing values, ensured no duplicates or invalidates, and trimmed white space in text fields. Finally, we added new features and rounded numeric values for consistency.
In this project, we focus on the data visualization using Power BI to analyze the global supershot dataset. Data visualization is an important part of the data analytics. It helps us understand patterns, spot trends, and make data-driven decisions using the tools like chart and dashboard instead of just tables and numbers. So our goal was to transfer raw data into an interactive dashboard that makes it easier to explore sales performance, customers' behaviors, shipping efficiency, and profitability. Now let's proceed with the first dashboard overview, which gives us a high-level summary of the business performance. So first, this is the overview dashboard, which is our first page of the Power BI report. At the top, we display three KPI cards that showing total sales, total profit, and profit margin in percentage. This gives us a quick snapshot of the overall performance. On the right, the line chart shows the monthly sales trend over time. This is helpful to spot the seasonality of monthly with spike or drop in the performance. On the bottom left, we have a bar chart showing the sales by region, which help us identify the geographical area which contribute the most to the revenue. At the bottom left, right, we use a pie chart to break down the sales by customer segments such as home, office, corporate, and consumers. Overall, this dashboard gives us a clear picture of how the business is performed across different regions, customer segments, and the time period. In this dashboard, we analyze the shipping performance across different modes and regions. First, we calculate the shipping duration, which is the number of days between the order and the shipment. This gives us a practical view on how fast our delivery are. So the average shipping time is highlighted on the top using the KPI card. On the map, we see the total sales by the country, which help us identify which region contribute the most and where shipping need to improvement. We also compare ship modes in bar chart. For example, we can see the standard class has a highest number of orders, but it takes longer on the average. Lastly, the tables provide detailed inform about every order, including shipping time, giving deeper insight when fulfilled, filter by region or ship. This dashboard explores which products and customer are driving business performance. On the donut chart, we break down sales by the product category, allow us to compare how technology, furniture, and office supplement supplies are performing. The bar charts also show the top selling product, helping identify which items are most in demand. The customer table gives us a breakdown of key customer details such as region, segment, sales, and profit, helping to identify our high-value customers. Lastly, for the tree map, it displays the sales distribution by subcategory. It also emphasize which product areas are bringing the most revenue. We also add slicer to filter so we can explore specific segments or region interactively. Finally, this is the section of the dashboard which focus on understanding how discount impact profit. The bar chart highlights average profit margin by subcategories, helping us to pinpoint which product groups are the most and least profitable. Our KPI card summarizes the key business indicators such as total sales, total profit, and average discount across all orders. Finally, the scatter plot at the bottom right shows the relationship between the discount and profit. Each dot represents an order, and we can clearly spot where higher discount may be leading to negative profit.
In conclusion, this project successfully demonstrates the use of data analytics to transform raw transactional data into meaningful business insight. From data cleaning and transformation in Python to interactive dashboard design in Power BI, we explore key areas such as sales trend, customer behavior, profitability, and shipping efficiencies. The dashboard we developed provides a clear and intuitive way to support the data-driven decision-making across multiple business dimensions. While the current dashboard delivers the strong foundation insight, and there is room for future improvement. For example, integrating real-time data through APIs would make the dashboard dynamic and useful for ongoing business monitoring. Incorporating advanced techniques like forecasting and clustering could enhance its predictive power, while design features like drill down and tooltips could improve the user engagement. Expanding the data to include the external sources like macroeconomic indicator or competitor pricing would also offer more context for strategy planning. Finally, deploying the dashboard through Power BI service with refresh schedule, access control, and mobile support would increase its accessibility and real-world usability. Overall, this project not only helps us gain wearable analytical skill, but also lay a strong foundation for building a scalable and intelligent business intelligence solutions.